out in your book. Okay, hopefully that's big enough for the camera. So my first example, I have a 81 to the power of -1/2. So I've got two things going on with the power here. The first part that's happening is it's a negative, and the second part that's happening is it's a fractional power. So I'm going to just deal with each one of those things one at a time. The first one I'm going to manage is this negative sign. So when I have a negative power, this is what we talked about in the previous lesson, or in the previous examples that I've provided you. When I've got a negative power, this power is saying, I'm not happy, I'm in the wrong spot, I need to be moved. And the place that I move that power is I drop it to the bottom line of the fraction. So I put it to the bottom line of the fraction. I keep the same value of the power, but it's now a positive number. And then on the top line, I've got nothing left. I can't have 0 on the top line. If I put 0 on the top line, then everything equals 0. So we're actually going to have a numerator of 1. So the first thing I do to manage that negative power, I drop the 81 to the power of 1/2 on the bottom line. Second thing, I now have to manage this fractional power. The way I evaluate and work out fractional powers is I use our roots. So square roots, cube roots, fourth roots. The denominator of this fraction is 2, so this is going to be a square root problem. So my fractional power, power of 1/2, is the same as having the square root of 81. Do I need to write the 2 here? Do I need to write the 2 here? No, I do not. When we have square roots, we don't put the little 2. If it's a cube root, fourth root, fifth root, we always put the number. So I don't need to have the little 2. Final step, I can simplify this further. What is the square root of 81? 9. So my final answer is 1/9. All right. Example 2. Okay. Same idea, but a little bit different now because I don't have a 1 on the numerator. So if I want to evaluate this, I'm going to use this rule here, and I'm going to split it up into a fractional power and a whole number power. So this 64, I'm going to write as 64 to the power of 1/3 to the power of 2. Can anyone tell me why I'm allowed to do that? What index law am I actually using here? Chelsea, do you know which index law we're using to split it up like this? Like, what's going on there?
You just times them together.
I times them together. How come?
Index law number 4 and 5.
Index law number 4 and 5. If I have a power to a power, then I multiply the powers. And 1/3 times 2 equals 2/3. Perfect. My purpose for doing this is it allows me to simplify this now. I don't know what 64 to the power of 2/3 is, but 64 to the power of 1/3, I'm going to rewrite that, dropping all my whiteboard markers. I'm going to rewrite that as a root problem. I've done something wrong. What have I forgotten? Where do I put the 3? Okay, how come I put a 3 there? Because that's the denominator of my fraction. So I've got to do the cube root of 64 in this case. What's a cube root of 64? What number multiplied by itself 3 times equals 64? 4. It is absolutely 4. So the bit inside the brackets is now equal to 4, and we've got a squared on the outside of the brackets. What do you think my last step is going to be? I'm going, what was that word we had before? Evaluate. 4 to the power of 2 is? 16. So there's my final answer. And I'm disappointed that I messed up my colour coding here. I'll see if I can get it right on the next one. Okay. On the weekend, I was emailed for some help on questions like this one, and I made a couple of videos. I don't know if you saw them. They've been posted on Google Classroom if you want to have a look. This kind of problem has changed. What have we changed in this problem? The bases. What about the bases? The bases aren't all the same. Remember that I've said a few times now, these index laws only work if they have the same bases. These don't have the same bases. So the first thing I've got to do is I've got to get the same base. Now, you might recognise 2 is a prime number, so that's perfect. I can't simplify the 2 anymore, I'm just going to keep that. Hopefully you know that 4 is the same as 2 to the power of 2. Did you know that 4 was the same as 2 to the power of 2? Yep. So I'm going to rewrite this to have a base of 2. Did you also know that 16 is 2 to the power of 4? Some of you would. Some of you might kind of go, oh, I didn't know that, I forgot that, I wasn't quite sure. If you're ever unsure, you can break up this value into its prime factors just by using a factor tree. So 16 is the same as 2 times 8. This is prime, can't go any further. 8's the same as 2 times 4. This is prime, can't go any further. 4 is the same as 2 times 2. So this 16, really hard for me to talk over a few people. This 16 is the same as 2 times 2 times 2 times 2, all of those prime numbers, which is 2 to the power of 4. In this question, if we ever have different bases, the first step that I'm going to take is I'm going to rewrite these bases and get them down to their prime factors. So 2 is already a prime factor, I just keep it. It stays exactly the same. It becomes 2 to the power of 3 over 2. Times. 4 is the same as 2 squared, and it's to the power of 1/4. And 16 is the same as 2 to the power of 4, and it's to the power of 3/4. Okay, so first step, prime factors for my base. Second step, now we're just going to work through our index laws. We're not going to worry about fractions, we're not going to worry about negatives until I get something that's more simple like these two. All right, so what I'm going to do next. These are a power to a power. When I have a power to a power, what do I do with my indices? I times them. So I haven't done anything with that first one, but the second one's going to be 2 to the power of -1/2. How come it's -1/2? Because 2 times -1/4 is -1/2. 4 times -3/4 is just -3. Okay, 4 times -3/4 is just -3. The times by 4 and the divide by 4 cancel each other out. Okay, first step, taken. I've got my prime factors as my base. Second thing, got rid of the brackets, powers to a powers. Third thing, what am I going to do next? Do I have the same bases? Yes. What's the operation between them? Times or multiply. So when we multiply, what do? You keep the base and add the powers. So keep the base, add the powers. What's 3/2 plus -1/2? 1. 1 whole. Okay. What's 1 whole plus -3? I'll do the extra steps here. This becomes 1 and then I've got to go plus negative 3, which becomes negative 2. So I didn't have to worry about fractional powers when I did the multiplication first. If I, back at this step, wrote fourth roots and square roots, I would have made a big mess of the problem. So I want to simplify it as much as I can before I try and evaluate the problem. When I have a negative, how do I rewrite this? 1 over 2 to the power of 2, and it becomes a positive because my power is now happy on the bottom line. It's a positive index. And 2 to the power of 2 is 4. Okay, this step here is what I would say simplified. This step would be evaluated, and this would be Mr. Boots' preference, I've got to think about how to spell that. My preference is that you write your answers with positive powers, not negative powers. Okay? Reason why I'm sort of like pushing this as my preference is I know many exam questions say write your answers with positive indices. So if this is our regular routine habit, then it's harder to sort of miss that direction in the question in future exams. All right? Are there any questions about that one? Yes. And in the video I made on the weekend, I did an example where we ended up with like a 2 to the power of 2 times 3 to the power of 1, and we would then work with them as two separate parts. Yeah, exactly like A and B. Exactly like A and B. Okay, what I want to do now, before I do too many more examples, because you've been listening for a long time, I want you to practice some questions from exercise 13B. Even if you haven't done 13A yet, have a look at the questions from 13B while it's fresh in your mind. We'll have a practice independently, and then we will come back and I'll do a couple more examples. All right? Okay, let's go.